grams of 4.97 times 10 to the 24th molecules, or representative particles, and I'm just going to go ahead and put that as particles, of copper bromide. The molar mass of the compound must be found before starting the calculation. So copper bromide, we would look up copper and bromine. Here's copper, 63.5, and bromine is 79.9. So we would go 1 times 63.5 for copper plus 2 times 79.9 for bromine, and that equals 223.3 grams. Alright, now we know that's the molar mass of copper bromine. Now let's go ahead and set up our equation. What is the mass? That's going to be our unknown. And 4.97 times 10 to the 24th particles is our known. Right? And we're going to grams. Alright, whenever there's 3 fractions, you can always put a 1 mole on the second fraction top and a 1 mole on the third fraction bottom. Alright, because particles is on top of the first, we want the word particles on the bottom of the second. And now we're ready to fill in our numbers. This was grams, so we would put that there. And the number always associated with particles is 6.02 times 10 to the 23rd. Okay, so the way we would punch this into the calculator, we would go 4.97, and then we would hit double E, which will take care of the times in the 10. We'd hit 24, and we would do our other numerator, times 223.3. I'll go ahead and hit equals at this point because we're at the end of all of our numerators. And we'd hit divide, and then we would hit 6.02, and then times 10 is the exponent button, double E, and then 23. Alright, and the answer is 1.84 times 10 to the third. You see we had 3 sig figs here, and we have 3 sig figs there. Number 9. How many molecules or particles are there in 9.98 grams of cesium carbonate? The molar mass of the compound must be found before starting the calculation. So we're going to have to look up, we're going to have to find cesium, and we're going to have to find phosphorus, we have to find oxygen, and we would do the molar mass of them. So 132.9. Did I say phosphorus? I meant carbon. Carbon is 1 times 12, and oxygen is 3 times 16. And all that together equals 325. Alright, and that's in grams. So somewhere in here we're going to have a grams that's going to need a number, and that's going to be it. Alright, let's write what we do know. We know 9.98 grams. Okay, now I can either go ahead and put grams here at the bottom, or I can go ahead and write down, remember how 1 mole on top, 1 mole on the bottom? Okay, and I'm going to how many particles? So particles goes here and here. Alright, so I need a number here, and I need a number here. So 325 will go here because it was grams. And particles is always 6.02 times 10 to the 23rd. So punching that into the calculator would be 9.98 times 6.02 times 10 would be hit in as a double E on our calculator. Oh goodness. 23. Then I hit equals. Then I hit divide because I'm going to do my denominators. And so then hit 325 equals. And strangely enough, this answer also came out to 1.84, but the exponent to the 22nd power. Number 10. How many grams of helium are in the Goodyear blimp? If the volume of helium in the blimp is 5.74 times 10 to the 6 liters at STP. The molar mass of helium is the atomic mass of helium from the periodic table. So helium has an atomic mass of 4. Okay, so we know that 4 grams is going to be helium's atomic mass, molar mass. Alright, so let's start putting our stuff in here. This is our known, 5.74 times 10 to the 6 liters. How many grams? So grams goes there and there. Alright, because liters is on top of the first, I want the word liters on the bottom of the second. And just as before in these other ones, on these 3 fraction ones, 1 mole can be written on top of the second fraction, and 1 mole can be written on the bottom of the third fraction. Alright, the number associated with liters every time we do in moles is 22.4. And grams is going to be 4. So we would do all our numerators times each other, so 5.74. Double E takes care of the times in the 10. 6 times the 4 equals, divide, because we're at the end of our numerators, and then divide it by our denominators, and we only have one denominator. Okay, and this one equaled 1.03 times 10 to the 6. We had 3 sig figs here, and we want 3 sig figs here. What is the mass in grams of 1.41 times 10 to the 24th molecules? Now remember, we can substitute the word particles here. Of copper hydroxide, the molar mass of the compound must be found before starting the calculation. So we're going to have to look up copper and oxygen and hydrogen either from the periodic table or from an atomic mass list. Okay. And we would say 1 times copper's number, which is 63.5, plus 2 times 1 for oxygen, so 216, plus, and 2 times this little 1 for hydrogen, so it would be 2 times 1 equals, and that equals 97.5. Alright, so now let's start on the question. 1.41 times 10 to the 24th particles is our known. Okay, what is the mass in grams? So G and G. Anytime we have 3 fractions with this kind of question, we can put 1 mole on top here and 1 mole on the bottom here. Because particles is on top of the first, we want the word particles on the bottom of the second. This was grams. So 97.5 grams is going to go here. And the number always associated with particles is 6.02 times 10 to the 23rd. So punching at the calculator, we would hit all our numerators in. 1.41 double E 24 times our other numerator 97.5 equals, divide all our denominators, and we really only have one denominator, 6.02 double E 23 equals. That answer is 2.28 times 10 to the second. And we had 3 sig figs here, and we have 3 sig figs there.